This presentation is going to be about finding the dose when you have a critical care drip. So what this means is, like, for example, you walk into your patient's room, you see they're on a critical care drip. So you can see what the pump is running at in milliliters per hour. And then you look at the concentration of the solution and you have to figure out what dose the patient is getting per hour or per minute. That's what I'm going to teach you in this presentation. And you're going to be expected to be able to do this when you're in clinical. So pay attention. It's also going to be on your doses calculation. Okay, so we're going to look at this first equation here. First thing I do anytime I have a math question is I look and find what this question is asking me. This question wants to know how many units per hour. So how many units per hour is my patient receiving? So I'm going to go and read the equation now. So I have an intravenous heparin drip is infusing at 22 mLs per hour, and the concentration of the IV is 40,000 units in 1,000 mLs of D5W. So in my bag, I have 40,000 units of heparin in 1,000 mLs of D5W. How many units per hour is the patient receiving? So I'm going to show you in dimensional analysis. And if you don't like dimensional analysis, just hang on because I'm going to show two different ways you can do this problem. All right, so in dimensional analysis, our X is always going to be what the question is looking for, and that's units per hour. So when we set up the equation, we make our numerators match, okay? And that makes it easy because you don't need to memorize a formula. So I have 40,000 units in 1,000 mLs, and I'm going to multiply that by the mLs per hour. And if you look at the equation here, I put the mLs in blue because that's what you're going to cross out, okay? And that's going to leave you with units per hour. So get out your calculators and keep this all in your calculators. So input 40,000, divide that by 1,000, multiply by 22, and divide by 1, and you get 880 units per hour. So 880 units per hour is what this patient is receiving. All right, now I'm going to show you a different way if you don't like that solution. All you need to do when you get a question like this is find the concentration of the solution in the units it's measured in, okay, and multiply it by rate. And that's going to give you the dose per hour. So in this case, we have the same equation. Heparin is infusing at 22 milliliters per hour. The concentration is 40,000 units of heparin in 1,000 mLs of D5W. So how many units per hour is the patient receiving? So to get the concentration, we're going to take 40,000 units and divide it by 1,000 mLs. Then we just multiply it by 22 mLs per hour to get 880 units per hour. Now, in this case, we didn't have to do any conversions because the answer is in units per hour, and our dose, our concentration, is also in units. So we didn't have to convert anything in this equation. Okay, now say you don't like that formula, okay? I have another formula for you, okay? And the people that really like the basic formula or the universal formula or the D over H times the Q like this formula the best. So all you're simply going to do is put the rate over how many mLs you have available times the dose available. So it would be 22 mLs per hour over 1,000 mLs, and you multiply that by 40,000 units, and you get 880 units per hour. All right, now let's do a different one. We're going to figure out micrograms per minute in this equation. So you have nitroglycerin, 50 milligrams and 250 mLs. That's in your bag, and it's infusing at 16 mLs per hour via the IV pump. How many mics per minute is the patient receiving? Okay, so I'm going to make my X. It's micrograms per minute. That's what this equation wants me to find. So in dimensional analysis, I make my numerators match. So I look at my equation and I notice that I don't have micrograms, but I do have milligrams. So that means that my first fraction, I'm going to have to make a conversion fraction. So it's 1,000 micrograms over 1 milligram. I'm going to multiply that by 50 milligrams in 250 mLs. Then I look at my equation, and the other ml I have is 16 milliliters over an hour, but I have to convert it to minutes. So I'm going to multiply 1 hour and divide it by 60. Okay, so I wrote the equation out the second time just in color so that you can see what you're crossing out. And that's going to leave you with micrograms per minute. Okay, so now keep everything in your calculator and divide 1,000 mics by 1 milligram times 50 divided by 250 times 16 divided by 1 times 1 divided by 60. And you get 53.3 mics per minute. It doesn't tell you where to round, so I'm just going to round to a whole number here. On your dosage calculations and on your exams, it's going to tell you where to round. If it doesn't, round to a whole number, but it will tell you where to round, okay? Now, some people don't like dimensional analysis. They're like, it's too many numbers. I just can't deal with it. I'm going to show you another way you can do this problem. So to get the mics per minute, all you do is take the concentration, okay? So the concentration, and you're going to put it in the correct unit. So this equation wants to know micrograms per minute. So I'm going to convert 50 milligrams to 50,000 micrograms divided by 250, and that gives me 200 mics per ml, okay? So I multiply 16 times 200 mics per ml, and that's going to give me the amount per hour, but I need it per minute, so I'm going to divide by 60. That's my conversion factor. So that's going to give me 53.3 mics per minute, or 53 mics per minute. Okay, now say you don't like that formula. I have another formula for you. You're going to put the mLs over each other. So I have 16 mLs per hour. I'm going to divide that by 250 mLs. I'm going to multiply that by 50,000 micrograms, okay, because 50 milligrams equals 50,000 micrograms. And that's going to give me 3,200 micrograms per hour. But then I need to change it to minutes. So all I simply do is divide that by 60. And I get 53.3 micrograms per minute, or 53 mics per minute. Okay, so first step, find what you need to solve. Then you're going to set up your equation, whatever formula you like. Keep everything in your calculator when you're finding what the answer is, and then round at the end, and then ask yourself, does this make sense? Now, you have an hour for your dosage calculation test, so if you have more time, now remember, you can't go back, but if you had more time, you could do dimensional analysis and then maybe follow it up with the shortcut method if you think you're going to have time. But if not, I would do a lot of practice on these. ATI has some great modules that you can do to practice. And of course, you have all the practice questions I gave you. So I would do those over and over. Practice makes perfect.